Hey, hi guys, welcome to the channel again. In this section, we will be discussing on logistic regression. Let me just make the slide bigger here. So basically, what logistic regression is used for is categorizing the data, right? Whenever you need to classify a data using a learning model, the most simple methodology that you can use is algorithm that you can use is your logistic regression. So basically, classification will be of two types. Either it will be a binary data, right? Either it will be a yes, no, or for example spam, not a spam, uh, a yes no kind of a classification, or it could be a multi-class classification, whether it is a cat, it is a dog. uh, we'll go through the simple one, which is a yes no kind of a classification as of now. The limitation of this model is assumes a linear relationship in log odd spaces. So it is we discussed, right? It is either a yes or no. If it's a complex non-linear relationship, right, it might not be able to give you the solution unless you use feature engineering or the polynomial terms that we discussed, the polynomial we did discuss last in the last two lectures, right? Coming to the advantages, it is simple, works well when there's a linear relationship. Output probability is useful for decision making, right? So basically what we do in oh my bad. Okay, what we do in logistic regression is, right, in linear regression we give an equation, right? Let me pull up an image. Do I have anything of a linear regression? I don't think so. Let me check if I can pull up an image of linear regression to show you guys what linear regression actually means, so that it will be helpful for you guys. Let me just put this up. Okay, I had this image. So if you look over here, right, this is linear regression, how this is working. So basically you have X and Y relationship. Here for logistic regression, we pass the output through a steminoid function, right? Also call it logistic function. We where so this is what the function is, right? So what it will give you is it will always help to get us a value of 0 or 1, right? Probability of getting the output of 0 and 1. So this is what the steminoid function is. Now I'll move this across. My bad. Yeah, this was steminoid function is inputs any real number, output is either 0 or 1. Graphical representation, uh, very very negative value, output is 0, very positive value, output is 0. Smooth as kind of a graph. Decision rule is this is what we discuss. Greater than, so it is all about how you want to predict your value, right? If x value is greater than zero point 0.5, it predicts 1, otherwise it predicts 0. This is, so and we can define threshold, right? Assumption is the dependent variable is binary and 0 or 1 for uh, we get an output as the value, the variable on which we are dependent is always 0 or 1. Independent variable can be continuous, category, or mix. Yeah, so independent variable, which is your x right over here, you can see, or this is your independent variable and this is your dependent variable, right? And what is next, man? Yeah, there's a linear relationship between log odds of the dependent variable and the independent, so it's kind of a linear relationship. So where it will be only able to solve your problem, and then it's a linear kind of relationship between the x and y variable. Yeah, we'll conclude this session. We'll go through in details and the python code in the next section. Yeah, thanks everyone.